Now let's get into the fun part of expanding a binomial. When we get into this expanding, what we're going to do is we're going to use what we did in example 1 and 2 to help us find our coefficients. So when we find our coefficients, we're going to be able to use our C sub numbers or whatever. This will make it a little bit easier. So what we're going to do here on example 3 is says we need to write the expansion of the expression x plus 2 to the fourth. Well, the reason we do this binomial theorem is because otherwise you would be taking x plus 2 times x plus 2 times x plus 2 times x plus 2, have to multiply all those together and come out with getting some type of x to the fourth, blah, 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 blah. So that would take a little while, but if you do your expanding a binomial with the binomial theorem, it can be a little bit quicker. So now, what we're going to have is we're going to have to find our binomials. So our binomial coefficients. Those can be found by using what we did in the first couple examples with our C and our factorials. So our binomial coefficients, we're always going to start off with your highest degree, which is a 4. So we're going to say C sub 4 is 0. We're going to find some number for that. Then we're going to have to do then we're going to get to our third term. So we're going to say that's a comma. So we're going to have a 4c sub 1. That's going to equal some number. And then we're going to have a 4c sub 2. This is probably, yes, you guessed it, is going to go all the way down to a 4c sub 4. Because you're going to start with your degree is in the front, that's your n. And then your r, you just keep going down until you get to this point. So now if we remember how to find our 4c sub 0. Well, remember if you have a 0, back here in our first example, if we end up with a 0 on the bottom, then what we end up with is just a 1. The reason we get that is because if you take, this just means you have a 4 factorial over, well, 4 minus 0 is a 4 times a 0 factorial. That's just going to end up and give you a 1. So anytime that these two numbers are the same, or sorry, you have a 0 on the bottom, or if they are the same, they're always going to end up equaling 1. So there you go. That's a nice little shortcut there for you to remember. Now if you have a 4c sub 1, that means you're going to have a 4 factorial over 4 factorial 1 factorial. And so, or sorry, not a 4 factorial there, that's going to be a 3 factorial. So take that out. So remember, we can do our shortcut. 1, 2, 3 is going to cancel here on the bottom with 1, 2, 3 on the top. So you're going to have a 4 divided by 1 gives you a 4. Now if we have a 4 factorial over 4 minus 2 factorial times your r, which is a 2 factorial, 1 and 2 cancel. Really on the bottom you just get a 4, right? And on top, those cancel out to give you just a 2 times 1 times 2 times 3, which is just a 6. If you have a 4c sub 3, this becomes a 1 factorial times a 3 factorial. Oh hey, what do you notice about these two right here? They are probably going to end up being the same. And they are. So you end up getting a 4 right here. So those are all of your coefficients when you expand your expression. Now the way to find your actual expression then from here is going to follow a lovely little formula you're going to pay special attention to. In fact, I'm going to leave a little bit more room here to write out. Let's move this up. Touch. There we go. And so if we're going to start with an x plus 4 to the fourth, sorry, x plus 2 to the fourth, then what we're going to do is we are actually going to use our binomial expansion that we had at the very beginning. Each of your terms is found by using, here's your coefficients, and then we're going to find our terms. It's going to kind of look like this. So what we're going to do on this example, you have to follow along and see if you can find the pattern. So if we have we take our coefficient and we have a 1, That's our coefficient from up above. Actually, let me make that in purple. And what we're going to do with that 1 is we're going to have to multiply it by take your first term, take it to the fourth. So we're going to say x to the fourth. Now your second coefficient is a 4, so we're going to say plus 4. Now what we have to do here is we have to follow the formula of x to the, you take 4 minus 1. Well, what would be your next term here? Well, it makes sense that it would be an x to the third. So we reduce our coefficients. Now what we have to do is we also have to use this 2, that's your second term in your binomial, and we're going to multiply this by a 2 to the first. Then we're going to go to our third term in the middle. We're going to say we have 6, that's our coefficient we found up here. We're going to have an x to the second because that is going in descending order. Now your 2, which is your term here in the middle, or sorry, your second term here, this is going to be a 2 to the second. Now why didn't we have a 2 here? Well, this really is a 2 to the 0, right? Which is a 1. Sure, that makes a little bit of sense. So then we're going to have plus our 4 up above, and we're going to have an x to the first, and then we're going to have a 2 to the, you guessed it, third. So notice how your first term is going in descending order, 4, 3, 2, 1, then we're going to have a 0, and your second term of your binomial is going in ascending order, to the 0, to the first, to the second, to the third, and eventually to the fourth. So our last term, your coefficient up above is a 1. We're going to have an x to the 0, which just means we're not going to have one, and then 2 to the fourth. So let's simplify this all out, and you're going to end up with an x to the fourth plus, well, 4 times 2 is 8, so you have an 8x to the third plus, we have a 2 squared, which is 4, times 6 is 24, x squared, plus, now we have a 2 to the third, which is 8, times 4 is 8, 32, x to the first, plus 1, well, this x to the 0, that just basically cancels out, right? If you have anything to 0 power, that just cancels out, plus 2 to the fourth, which is going to give you a 16. So I think we probably better do another example like this, right? Yeah, I was kind of thinking so too. But that is how you can expand a